All right, there we go. All right, so thank you everybody for coming to the workshop tonight. We are going to learn how to get good.
Great joke, LOL.
Thank you, thank you. All right, so we're going to go over a couple of things. And the first of that is going to be just go a brief overview of some basic information and concepts that we need and that we'll be using throughout the rest of the tutorial tonight. So Amneet is going to start us off by explaining a couple of things.
Okay, sweet. So to begin with, we want to go over why Git is so important and why Phantom uses Git, and other companies that you guys may work with after graduation will probably be using Git. So two big reasons that you would use Git in a project is, first of all, it provides version control. So it lets you save your work at different stages. And this is useful because A, you have a history of the changes that have been made over time. And B, if you ever need to go back to a specific version of your project, you can do so. And the second big reason why Git is used is because it allows multiple people to be working on the same project. So you can branch off a main repository, you can make your changes, and then once your work is reviewed and tested, it can be merged back into the master copy of your branch, of your project. So we have Git and we have GitHub. And sometimes the difference between the two is a little bit vague. So we also just wanted to go over that. So Git is the actual system. It's open source and it's distributed, and it's a version control system. So distributed is important because what that means is that you can have a remote repository on a server that's accessible by everybody who has access to that repository. And then you have a local repository that's just on your own computer. And the work that you do on your local repository doesn't impact the work on the remote repository until you commit and you push your changes. So GitHub is simply an online host for your remote repository. So we have a Team Phantom GitHub that stores a copy of all our files and our revision history. So repository is another word that's thrown around. And essentially, it is the history of the project. So it's all the files that are in your project, plus all the changes that have been made to them. As I mentioned before, you have a local repository and a remote repository. So the local repository are the files and the commits that you've kept on your computer. And the remote repository are the history and the files that are kept on the server. In our case, that server is GitHub. And these are accessible by all the developers. And the next piece of terminology is cloning. So cloning is just creating a copy of a repository. So for instance, you would clone a remote repository into your local repository so that you can make changes to it. All right. And also we have branches. So a branch is a version of the repository. And it's an independent line of development. So what that means is that you can have your main repository and then you can branch off of it and work on one part of the project that is eventually merged back into your master branch. So as you can see in the little image that's on the bottom left there, you have your master branch in green, and then in blue, you've branched off, you've made whatever changes you need to make. Once your changes are complete and they've been tested and they're not going to break master, we can merge them back into master, and you end up with one complete project. So branches are super useful because different people working on different features can be creating their own branches. In GitHub, we can keep track of multiple branches, so we can continue to push commits to them and have that history until we're ready to merge them back into master. So on the right, I just have a picture of the BMS, all the different branches that are in the BMS repository. So you can see we have branches for like integrating CAN or implementing the BMS state machine. So in those branches, we're doing that work. And once that work is completed, we can push it back to develop. Okay. So the next few slides of terminology are kind of going between your working directory and your remote directory. So there are 3 different parts to getting changes in your local repository to be reflected in the remote repository. And so I'm kind of going to go through them and explain why each of them is important. So first you have staging, and this is kind of where you prepare your snapshot or the version that you want to save. So you can choose what files and what lines of code you want to include in this version. So in the picture in the bottom, we can see that going from your working directory to the staging area, you use the git add command, and that is like the staging process. So after you're in your staging area, you actually create your snapshot. So this is a version of your product or your project that is recorded. It's referenced with a commit ID and with a commit message. And so you can see in the picture below, you go from your staging area to your local Git repository using the commit command. And finally, there's pushing. And this is when you upload your commit into the remote repository. Okay. So going in the other direction, from the remote repository to your working directory, we have fetching. And so fetching is when you download your commits and files from the remote repository to your local repository. This is a safe way to review the commits before actually updating your files. So in the picture below, you can see like going from your remote Git to your local Git is a fetch. And then you have pulling, which is like more automatic. It downloads the commits and files from the remote repo to your local repo, and it will also update your working directory to match that content. And then there is checking out. And so checking out is just changing like what you're working on at the moment. So it's switching to a different version of your repository from your local repository. So you can check out a specific branch, but you can also actually check out specific commits that you've recorded before. When you're checking out, you need to have a clean working directory. Nice. Sorry, I paused there because like the slides just stopped for a second, but they're back. So when you're checking out, you need to have a clean working directory. You can't have any changes that haven't been committed. So if you need to check out a different branch or a different commit, but you're not ready to commit the changes that you're working on, what you want to do is stash them. So stashing is saving your changes temporarily so that you can work on something else. And then you can just go ahead and reapply those stashes later when you're ready to continue working. Cool. So now that you've been working on your independent line of development, like your separate branch, and it's time to merge it with master, there are a couple of different steps there as well. So there's a pull request, and this is just a protocol in which a developer asks that the changes they made, so their separate branch, be included into the project main master repository. Yeah, this is usually just to allow for a reviewer or a third party to be able to go through the changes, make sure they look good, and kind of just add that layer of protection before your changes are merged into the main repository. And then once that is approved, what's going to happen is a merge. So GitHub has the main repository or the branch that's being merged into, and it has your branch, and it's going to automatically resolve the differences to create one single branch. If GitHub is unable to automatically resolve your differences, which can happen if, like in both branches, you've changed the exact same line of code, and GitHub doesn't know which ones to keep and which ones to discard, you get what's called a merge conflict. And in this case, the developer has to manually choose which changes to keep and which changes to discard when you're merging these two together.
All right, we have a question from Tanya. Um,
Hi,
so go ahead.
I have a question about stash. Is there like a command to like reverse the stash? Like when you like stash something and then you move to another branch, like when you come back, is there like a command you need to type in to get those stash things back, or is it just like there?
Yeah, there is a command. There's a command for stashing your changes and then for applying your changes. We go through the specific commands in the workflow a little bit later on. So we'll hit on that.
Okay,
Great
sounds good.
question, though.
Thanks.
All right, and so now we'll go into a little bit about the best practices of using Git. And so the first thing that we'll start discussing is development flows. So a development flow, it's just a methodology on how to use Git to accomplish work consistently and productively with a team of numerous people, because it helps to coordinate the actions that each individual on a team is going to take so that one person isn't doing one thing and somebody else is doing something totally different, and then work ends up clashing. It really helps to keep things organized and consistent. Um, and it's essentially like a framework and flexible tool that you end up adapting to the needs of the team. And so there's a lot of different ways that development flows can be done, different ways that they can be implemented. Um, And what it means is when you're using them, there's a set of rules that you follow or guidelines that kind of tell you what you should be doing at a particular moment in time so that overall you experience fewer problems. You and your team experience fewer problems. And there's a lot of different options of like development flows that have already been established. A couple of them are the centralized development flow, the feature branch, forking, and Git flow. We're going to talk specifically about the feature branch one. And in this one, every feature that you develop will get a branch of its own. So it will be, you'll create a branch on GitHub so that any work that's done on this particular feature is kept separate from the main branch until it's finished development, at which point you merge it back in, and then a completed feature is added to the main branch. So in this case, you don't end up with a feature that's half complete that's in the main branch. And so you always have a main branch that's working. Currently, Team Phantom, we do use the feature branch workflow in a lot of our work. As you can see in the image on the right, we've got branches where specifically can goes into, or like the foot pedal, analog to digital converter, etc. All of those are all different features that are all part of one larger project. And once those are finished, they'll all be merged back into the master branch. And the next development flow that we're going to touch on is Git flow. So this one, it's actually just a extension of the feature branch workflow. So everything that we just covered is also going to apply for Git flow. It's largely designed around scheduled project releases, and is often used in combination with continuous integration, which we're not going to touch on today. But for example, in the case of Team Phantom, like this might be applied in such a way that like the scheduled project release is when we have to have the car finished by. And so in such a situation, we could end up using it. It can be really helpful with embedded projects because embedded projects are often highly dependent on the hardware that they're to be used with. And so you can create releases that are compatible with certain hardwares, and it makes it a lot easier to keep track of these types of releases. So in addition to just feature branches, there's a couple of other additional branches that are used. And I think a notable thing is that the master branch isn't the main branch that we use in this development flow. The main branch is develop. So all of your feature branches, they get branched off of the develop branch. And when they're completed, they get merged in with the develop branch as well. When everything is ready for a release, that's when things get merged into a master branch. And that branch is what serves to track the different releases that are happening. And oftentimes there will be a couple of bug fixes in the process before that gets finalized. It's very scalable for large teams, and a couple of the Phantom repos are currently using it. And so now just some general best practice points. We'll cover a couple of different areas. I believe there's 5 areas we'll cover best practices for. The first is going to be branches. Branch names should be short but descriptive. So if you're doing work on an ADC, your branch name should probably be something about what you're doing with that ADC. And you should only do work related to that branch while you're on that branch. If you're going to go and start working on something else, at that point, you need to go and create a new branch because it helps to keep your work organized. And it also just helps the team make progress in a continuous way because then you're not working on 2 things at once. Which can cause problems if you're finished one feature, but you're still working on the other. And only ever branch off of the master branch or develop if you're using Git flow. This isn't done automatically. So before you make a branch, always do git checkout master before you try and make a new branch. The next, oops. Oh no, what happened? Wouldn't be a presentation without some technical difficulties. Okay. So the next area of best practices we'll cover is for committing. So when possible, commit useful chunks of work. Don't do a little bit of one part of your task and a little bit of another part of your task, because sometimes what happens is you need to undo a commit. This may be tomorrow, or it may be like in 2 months from now that you need to undo this commit. And so if you have your chunks of work separated in little chunks that make sense, if you eventually need to undo it, or you need to go back and refactor some of that particular work, it makes it really, really easy to go back and look at that later on. And also, you should make your commit messages useful to describe the work that's in that particular commit. Because again, that loops into the previous point of if you need to go back later, it makes it really easy to identify. And on the point of useful commit messages, you should keep them short and easy to read. A good rule of thumb is 50 characters or less. So think of just a really, really short sentence. And it should be written in the imperative verb tense to just increase readability when you're going back to look at it again. So for example, add unit tests, implement IMD driver, remove faulty EEPROM code. All of those are great commit messages. They follow all of the different rules that we just discussed. The next thing we'll talk about is best practices for pushing. The only point I have here is never push directly to master or develop. Just don't do it. Push your code to a branch that you make and then create a pull request if you need that code on master. If you remember one thing from this presentation, just remember that. Trust me. And so that brings us to pull requests. Make your pull request once your feature is finished. Master and develop are branches. They're supposed to have clean working code. If you put half-finished features on them, it might interfere with like everything working properly because it may cause faults, it may cause crashes, it may cause it to simply not compile. So try and keep your pull requests, keep the code on master nice and clean, and also just don't keep branches sitting there forever and ever, because otherwise eventually the code gets outdated and then you have to update things before you can think of integrating it into the master branch, and it just ends up being a little bit of extra work. And once you've merged a completed feature into master or develop, just delete the branch. It helps to keep the repo clean and avoids cluttering. And it's just unnecessary to have those around. And the final point is for pulling and merging. Pull new changes often. So before you start working every day, just go and do a git pull master to bring any changes from the master branch into your code. And that will just prevent any problems. It will keep your branch up to date. If your friend adds a new feature at 2 a.m., you'll have that new feature in your code when you start working. And that will help you to avoid merge conflicts, which we'll talk more about later. And then when you pull the new changes, always merge them into your different feature branches. So now we'll have a quick quiz about what we just discussed. So just type your answers and send them into the chat. So question 1, which of the following does GitHub not do? Provide a history of the project, enable people to work together on projects, automatically updates your local repository, or keeps track of different versions of a project. Which one do you think this is? All right, it looks like C is the unanimous answer. What do you think it is, Amneet?
I think I'm going to go with C as well.
And you are all correct. Good job, guys. All right, question 2. What is committing? A, when you commit to including a particular change, to include them in the master or develop branch. Creating a recorded version of the project that can be referenced by a unique commit ID, adding a short message to describe a chunk of completed work added to the project history, or is it uploading a set of changes from your local repo to the remote repo? All right, I see a couple of Bs, a couple of Cs. I'll wait for a, and we have an E. All right, so the correct answer is B, creating a recorded version of the project that can be referenced by a unique commit ID. So this is something that Nate talked about earlier, where when you create a commit, there's a message and there's also an ID that you can use to reference that. It's not C, but C is a valid point. That would simply be a commit message. All right, question 3. What are key ideas in the feature branch workflow? Select all that apply. There is a consistent set of rules to guide how the team uses branches. There are guidelines on how and when the branches interact. New features are developed without interference from other features, so they can be included as soon as they are complete. And the master or develop branch contains complete working code at all times. What do we think for this one? All right, we've got a couple of CDs. We've got an A in there as well. We've got an all of them. Do we have any more guesses? So our late guessers are right. I can see you celebrating, Tanya. All right, so moving on to question 4. This one should be a little bit easier than the last one. What's a good example of a commit message? Majorly refactored code, database, rewrote charger firmware, or implement UART comms. So this is going to be part of the best practices that we covered. All right, a lot of, yeah, yeah, B, just database. So yeah, you guys were all right. It's implement UART codes. It's written in the imperative verb tense. It's nice and short, and it describes exactly what we're doing. And now the last question of the quiz. Which of the following isn't a best practice? Commit related chunks of code together. Only pull new changes into your branch once your feature is working. Never push directly to master or develop. And only branch off the master or develop branches. What do we think for this one? All right, we've got a couple of Bs, a couple of guesses for A as well. But it looks like most people think B. And that one's correct. So you want to pull changes into your branch as often as you can. Honestly, whenever there is a new change, that's when you should be bringing it in if possible. But just try and check often because unfortunately Git doesn't have a handy little notification button. Somebody should go work for GitHub and add that. Okay, so that concludes our short little quiz. So we're going to start with just getting set up with Git now. And then we might take a short break, depending how we feel.
Cool. Okay. So there are two main ways that you can interact with Git on your computer. I'll be going through the method that I use, which is just using a simple text editor and a Git client to review my changes later. And Courtney will be going through the second method, which is using an IDE, and she's going to be going through VS Code. So how I like to work with Git on my computer is I use Sublime Text as my text editor. And yeah, it's super straightforward. It's just a simple text editor. You could honestly use something like Notepad++, just as valid. It doesn't come with anything fancy. But when I'm working with my entire repository, what I find helpful is to just start with adding my entire folder to my project. And I choose my entire repository to be in my little Sublime Text window. And the reason I find that helpful is because then you can take advantages of some of the shortcuts that come in text editors. So you can do things like right click on a function name and get to that definition, or Control F and search for a word or phrase through the entire repository. But other than that, there's really nothing fancy with Sublime Text. So then when it comes to when I'm ready to review and stage my changes, I use a Git client. The one that I use is called Fork, but another popular one that I've heard a lot of people use is SourceTree. So similarly to how I add my repository to Sublime Text, you do the same thing in Fork so that it can track the different commits and changes that are being made in that repository. So it's super simple. You click File, Open Repository, and you select the folder that you want to include. Yeah, so there are two main windows in Fork. The first one is the first one that pops up, and it essentially shows you your entire, like a visual representation of your entire repository. So in the purple box, you can actually see the different branches in your repo and how they're interacting, and the different merges that were made, or sorry, the different commits that were made, the users that made them, and the commit IDs. And then if you look below in the orange box, once you've selected a commit, it shows you details, such as your commit ID, the commit message, and actual files and different changes that were made. And in green, you kind of get perspective on the branches you're working on, your remote repositories, and what's in your stash currently. So the second main window that Fork offers is the changes, and this is what's actually been changed in your working directory. So this is useful when you're doing the staging part of going from your local repo to your remote repo. So this is where you actually choose the files, and sometimes if you're really picky with what you want to add in your commit, the actual lines that you want to stage. So in the unstaged box, there's a list of all the different files that have been modified in your working directory. And once you click on a file, you can see in the right you get an overview in a text editor of the changes that have been made. So to select a file that you want to stage, you can just click on that file and then hit stage, and it will move from the unstaged area to the staged area. If you want to choose specific lines, you work in the text editor portion, so that view on the right, and you just highlight the line that you want to commit, and then you hit stage. And you can see that the things that you're staging are being moved below to the staged area. Okay. So once you stage your files, if you need to unstage them, there is that reverse command. So there is that unstage button. But once everything looks the way you want it to look, you can move on to the committing portion. And so in the bottom, there's a field where you can type in your commit message, and then you hit commit. And so that creates your commit with the ID and the recorded message. And then you're ready to push your commits. You can do this through fork, or you can do this through the command line. Pushing through fork, it's an option under the repository menu.
Okay, and so you can also do all of these things through an IDE. The one that we're going to be using is VS Code, at least for these examples, though any IDE that you can use is going to be relatively the same. So in the menu bar of the editor, you select, again, you can do the same thing as the text editor and open up the entire project in the repository. And then from there, you can go and select new terminal. And that's going to open up a command line that's right in the like IDE itself. So it'll be on the bottom half of your screen as seen here. And it will be opened in the same working directory that your the root of your repo is in. And anything that you need to do for Git, you can do through these command line interactions. So you can stage things with git add, and then the file path and file name. You can do git commit and add your your commit message through there. You can do pushing, and you can also pull changes in from there. And there's also a GUI interface for this. So on the very, very left-hand side of the screen, you can see the little like branch thing with the notification here. Like through there, you can go and access all of the different graphical interactions. And you can then, I think it's through right click, that you then get all of these different options to do everything from stashing to adding tags, which I don't think we really use, but you may end up using such features out in industry. So we'll do the first step of doing the setting up Git, and then we'll have like a 10-minute break, I think. Are you good with that, Amit? So to add Git to your computer, you just need to do a couple of steps that will vary depending on what your operating system is, but whatever it is, it's going to be an easy choice. So if you're on Mac or Linux, you just have to open up a command line, and then all you need to do is enter the commands that you see on screen there. It really shouldn't take you more than 2 lines to get it done and to get it downloaded. And if you're on Windows, it's easier to just download the file off of the website that you see there. And what this is going to do is it adds the Git toolset to your computer so that you can use Git through your command line. You can keep track of branches, all of that type of stuff. So if you guys haven't downloaded Git onto your computer now, I want you to either go to this website here or open up your command line and download Git, because we're going to be using that after the break. So before the workshop, I got you all to go onto GitHub to make an account if you hadn't yet. So hopefully that's all taken care of. And what we're going to do now is we're going to set up our GitHub on our computers so that it's ready to use. By doing these next few steps, it's just going to make things a little bit simpler when you're trying to pull and push from repositories that have some kind of protections on them, which is the case for the Phantom repos. So open up your command line, and the first thing that you're going to do is git config -- global user.name, and in parentheses, I want you to put your username, the username that you sent to me in the sign up sheet for this workshop. I think either is fine to use, either the command line or the Git specific one. What version? The most recent version. Yeah, the most recent version. I can't comment beyond that.
I think it's accurate. Like for Windows, it's like 2.30.2, but it might be different for different operating systems. But using the commands for Linux and Mac, you should automatically have the most recent one. You're probably good.
Exactly. This is why Mac is superior, and Linux is also superior.
Hey, hardcore Windows, okay.
All right, and so then for the second step, you're going to add your password in. So again, in your command line, git config -- global user.password, and then in parentheses, add in your password. And once you've done that, you're going to add your email, the one that's associated with your Git or your GitHub account. So git config -- global user.name, user.email. I'm going to have to fix that. And then in parentheses, add in your email. I'm going to take no response as a good thing in that nobody's having problems. Is everybody ready to move on? No, you should not have any response. No, like I just said, no response is a good thing. You'll find this a lot for a lot of different command line things that you do, where if there's an error, it will let you know that there's a problem. But if everything's all fine and dandy, you're not going to know about it. It just moves on silently. But what you can do, you can check it by like git config user.name. And then at that point, it should tell you back what your username is so that you can make sure it's input correctly. I don't know if the same works for your password. That would be a little sketchy because then anyone could find out your password if they got to your computer. And then you can do the same thing with your email as well. It does give you the password. GitHub, hire me. I'll fix these things for you and add notifications.
The notifications is a great idea.
I don't know why they haven't done this yet.
You know, they have the, like, if you do Git status, it lets you know. But I guess it's only on your remote branch. It's like not on master.
Yeah. I'll be stealing as many passwords as I can when people ask me to watch their computers at random cafes. All right, so now we'll move on to the tutorial of working with Git. So I want all of you to go onto the Phantom GitHub. All right, we have the second lame joke of the night. The second lame joke of the night is brought to us by Pardeep of We're Getting to Work. Okay, so yes, it's time to get to work. So if you head over to the Phantom GitHub, some of you may find that you need to accept membership onto the GitHub. I just added everybody before the meeting, so you should all have access to it. And you'll see a repo called Git practice, I think it was. And so Amit will take us through the first few steps of working with our new repo that we're going to practice with.
Okay, cool. So as Courtney mentioned, you can go to the Git practice repo. And this is a repo that we're going to kind of run through like an entire cycle of working with Git for. So first, we'll get everybody to clone the repo onto their computer. So what you do here is once you've entered the Git practice repo, you're going to see this green button that says code. And then you can see it's going to have a URL under the HTTPS. So go ahead and copy that, and then go to your command line. Go to your command line in the folder that you want to clone the repository into, and then type in the command git clone, and then paste in the link you just copied.
You don't need to make a folder because what's going to happen is when you clone the repo, it's going to create a folder. And the folder is going to have the name of the repo that you're cloning into it. All right, so now what you're going to do, you're going to cd into the directory that you just cloned. Or if you're on Windows, it might be a different command.
Nope.
I'm not totally sure. Okay. So you're going to cd into the directory that you just made, and then the next, you'll do the following steps. Amit, were you going to cover these?
Sure, I can. Okay, so essentially we're going to get everybody to make their own branch. So the command for that in your command line is git checkout -b, and then you can put your new branch name in there. And I think it'll just be easy if everybody names their branch like their own name.
Don't do this in real life.
Yeah, please don't. Okay, so once you have created your branch, you need to connect your local repository with the one on GitHub. So all your changes are being tracked on GitHub. And we're not going to do this right now, though. So yeah, everybody can just create their first branch. And once we're good with that, we can make our first changes.
So it's at this point that you're going to open up your text editor or the IDE. All right. So, sorry, were you going to say something?
No, I just like, nice.
Oh, cool. All right, so now this is the moment where you're going to want to open up your text editor or the IDE, whatever it is, you know, or use Vim. Nobody's watching, so nobody's impressed, but you know, you do you. And at that point, we're going to want to make a change into your folder or into your local repo. So take a moment to open that up. And what you're going to do is you're going to create a new file in the repo. And I want you guys, the file name is, we're going to just put your own name down as the file name and I don't know, do a text file. And I need one volunteer. I need one volunteer before we can do the next step. All right, thank you, Pardeep. What's our theme going to be? Cars. I like it. Very on theme with Phantom. So in your file, you're going to put something car related. Just one word that's car related. And then I want you to save that file. All right, so you probably have finished that. So what we're going to do now is we're going to get ready to do the first push. However, before we do that, if you try and do the Git push right now, you're probably going to get, Git isn't going to be very happy and you're going to get a lot of errors. What you have to do first, like as Amit explained earlier on in the presentation, you have to stage and commit all of your work before you push it. So you're going to do a git add and then the file name. And then you're going to add a git commit -m and then in quotation marks, a commit message. And at that point is when you can do git push -- set upstream and then origin / your branch name. So I'll give you guys a few moments to do that and let us know if you guys have any problems.
That was super quick, Jay.
Oh, are you watching the GitHub?
Mm-hmm.
I think I have that opened up on my browser that's on like the same screen that I have the presentation. So I can't see any of GitHub right now. Yes, you're supposed to create a new branch. You can either do it via git checkout -b and a branch name, or there's ways to do that through like the graphical methods.
Andre, you didn't write anything in your text file. It's like an empty file. For the integrity of this presentation, I'm going to ask you to like type a word in your text file and just push it again.
Okay, you got it. I thought I named the text file of something car related.
No, you should, inside of your file has to be a word, a sentence.
You got it.
So Vlad, in your IDE, usually in the left-hand panel, you'll see kind of the directory of files and stuff. And in the top of that little panel, you should see a plus sign, and through there you can create a new file. Or if you right click in the left pane, that should also work. So for those of you who have already pushed your code onto GitHub, what you're going to do is you're going to go down a few lines in your file and you're going to start adding some more content. You may or may not know about the car part that you wrote down. If you want to, go ahead and write about it. Actually, let's have another volunteer. Who would like to choose the next theme? Just make it an easy theme, please. Whoever throws a theme into the chat first wins. Candy. All right, so I would like everybody to start writing a paragraph about candy, how much they love it, how much they hate it, why chocolate is the best candy, anything like that. So start working on that while we wait for the last branch to show up. So I'll give you a few minutes, just a minute to do this, because hopefully writing about candy is pretty easy.
And so the next step here is we're going to get you guys to stash the changes you just made. So this will be stashing your little paragraph about candy. And I believe that is on, that's a couple slides down, Courtney, if you want to like move up a couple slides.
Right. There we go.
Nice. Yeah, so we're going to get you guys to check out each other's branches. But before you do that, like we stated earlier, you need to have a clean working directory. So you need to stash these changes that you just made. So the command for that is git stash. So you just go to your command line, you type in git stash. And then if you want to see what your stash looks like, if you are curious, you can do git stash list. And it'll show you all the different things you stashed. So I'll just give you guys Pardeep, yes. So that was so you pushed your like word that related to cars. So after that we got you to write a little blurb about candy just in the same text file. So that's what you're gonna stash when you do git stash. Okay. I'm going to assume everybody is following along. And what I'm going to do is let me double check. Yeah, you did, Pardeep. That's totally fine. You can just go back to your pardeep.txt file and like write something at the bottom there and stash that. Okay. So while you guys are doing that, I'm gonna pair you guys up in the chat.
Oh,
And
I've already done that.
oh, cool.
I just haven't sent the message.
Oh, you can go ahead and
I
do
was
that.
doing that. Yeah, I was doing that so that it would be ready to go.
Nice.
So these are your partners for the next piece.
Yeah. So what you're going to do now that you've theoretically, hopefully, successfully stashed your changes, you're going to check out each other's branches. So the command for this is to do git checkout, and I'm typing this in branch name. So go to GitHub, look at what your partner's branch name is, and check that out. And I'll give you guys a minute to do that.
Is the branch name really long?
It's like new-branch-Raphael.
That's not that bad. I think during my first co-op, I made a really, like when I very first started, I made a really long branch name.
How long
Oh,
is
you know what?
Also, that's hilarious.
Yeah, and no need for new branch in the name.
Okay, so did I type git checkout to leave my branch first? Pretty no. So once you have a clean working directory, you can just do git checkout to hop over to any branch. Like you don't have to leave your branch or anything. Okay.
And so while we're here, I just wanted to point out a particular thing about branches. So to create a new branch, what you do here is you do a -b, and that's like an instruction to Git to create a new branch. But if you do git checkout without this, it goes to find an existing branch. And they're called flags. There's other flags such as -d that will delete a branch. And you can find a lot of these if you just type in like git -- help. But this is a common one that you'll need to use, so I just thought I'd point it out. If you want to know what branch you're on, git branch will give you the result of not only which branch you're on, which will be indicated by, I think it's green and a little asterisk, but it will also tell you the other branches that you have on your computer locally.
Yeah, so I just want to make a comment here. Because Ralph was having this error, I don't know if you all saw it in the chat, where Git was not recognizing the branch J. And we resolved in private chat, but basically the solution to that is to do git fetch. Type it into the chat. And we went over that command earlier. So what that does is it downloads like branches, commits files from the remote repository to your local repository so that your local Git knows about their existence. So if you find that your local Git can't find a branch or like a file, you can do that first and then you can check it out. Raf, yeah, that command will fetch everything that's in the remote repository to your local repository so you can review it.
All right, so who's managed to switch over to their partner's Git branch already?
Way to go, Jay.
It must be the Vim skills.
Okay, sweet. I think we've resolved some errors. I think. All right. So now what we're going to do is we are purposefully going to make a change that's going to cause a merge conflict so we can get some practice in resolving those. So you're going to go to your partner's original.txt file where they put down their car part, and you are going to change it to a different word. It doesn't have to be a car part. But go ahead and make that change and then push that change. So then you're going to do git add file name, git commit with your commit message, and git push. And I will type those commands into chat. Yeah, and you'll notice this time you don't have to do the git push set upstream because these branches are already being tracked in the remote repository.
On top of changing the word, I want you to, we're going to drop your, you're going to drop your stash into the file.
Okay, so working with git stash, you have two options for applying your stash changes. There's stash pop, which will just take whatever the most recent stashed change was, apply it, and then immediately drop it from the list. I personally would not recommend this one because it's kind of like one shot, and if you accidentally applied it to the wrong place or made some other sort of mistake, you've lost the changes that you stashed. So what I like to do is do git stash apply, and then if it's been applied properly, then I drop it manually by doing git stash drop. So git stash, yeah, it's on the slide. I will also type it into the chat. Yeah, since this was you guys' first stash on the repo, it's probably going to have the index number 0. To see which index number it is, you do git stash list. And then to drop the stash from the list after it's been applied. Was this correct, Courtney? We wanted them to switch back to their original branch, right?
Before applying.
The stash? Or is it?
I think so.
Doesn't matter. Okay.
Oh, we got a conflict. Interesting. The file is deleted in an updated stream and modified and stashed changes. And this is in trying to apply the stash. Oh, I think I know what's going on. Wait, is it? Yeah, I think I know what's going on.
What do you think is happening?
Because the stashed changes are associated with a particular file. So it's not just particular lines of code, and each of you all have a different file. And so what you're essentially trying to do is creating a new file in your partner's repo.
Right. So if we're getting conflict, I think that's okay, because this gives everybody an opportunity to check out back to your original branch, and then try to apply your stash changes. Is there a git abort that would work here?
I think there might be. So I'm going to send you guys a command in the chat that I want you to try. And hopefully it works. So that is 2 dashes in the chat. If you're getting a conflict error, I want you to do this if it doesn't let you check out your original branch. If it lets you go back, no problem, don't question it. You're one of the lucky ones. It kind of, git reset head is kind of like a rewind. So it undoes any changes that aren't in the original branch. So anything that you didn't merge or that you didn't push onto the thing into the remote repo, it just gets undone essentially.
Okay. So assuming, unless you guys have more errors, and you can drop them in the chat, but assuming you're good with applying your stash changes, we're also going to get you to change that first word that you had typed in to your file. So change it to anything else, something that was different than what you had. And then we're going to get you to pull the remote repo into your local repo. Yeah, because your partners, they made a change on the file and they pushed it, so you got to pull that into your own repo before you can push your additional changes. No, Raf, it should just be git pull. Also, Pardeep, your partner, cough cough Andre, failed on you. So I'm actually going to make the change and put it in your repo. So give me like 2 seconds. I got you.
Wait, he bailed?
Yeah, so he didn't change his partner's code. There. So for everyone whose poll aborted, like Pardeep's just did, go ahead and stage, commit, and push your changes. So git add file. And everybody's going to run into errors and let us know what they are.
These should be some fun errors that you guys get to see.
I think this entire workshop has been filled with fun errors. Jay, okay, hold up. I'm going to check up on your branch as well, Jay.
We'll
Oh, that's
give you some
because
errors.
you got an auto merge.
Oh.
Yeah. So I'm looking at like Jay's commit history.
So what's the error message that you got? Ooh, rejected.
Nice. Hurts. Okay, so like we mentioned before, like the Git hints are usually on point. So it's saying hint, integrate the remote changes, git pull before pushing again. So that's probably a good thing to try if you were getting this error. Finally, we got a merge conflict.
There we go. Nice.
Pre-mediating merge conflict, didn't expect it to be that difficult.
I know, right?
Yeah. So Pardeep, what does your error look like? Everybody who has a merge conflict, sit tight. You're in the right spot.
Yeah, if you have a merge conflict, this is exactly where we want to be.
Perfect. Okay, that's good.
That's the one we want.
Alrighty. Yeah, ain't that the truth? All right. So everybody that has merge conflicts, you can deal with these in your command line, or what you can do is hop over to fork, or I assume there's an equivalent in VS Code where it will show you the conflict and you get to pick.
So
like
in VS Code, what should happen is it should show two different versions of the file that have where the merge conflict occurs, one with the old changes and one with the new changes. And there should be some red and green highlighting throughout the file. So anyone who's using VS Code, let me know if you see that or not.
Same with fork, actually. So anybody who's using a regular text editor and fork, if you go into fork, it should show you 2 versions of the file. Yeah, and it should have little like arrows to point out which changes are conflicting. Okay.
Yeah, Pardeep, that's what it should look like. Something like that looks about right.
Mm-hmm. So you can see on the top is like your version of the file. On the bottom is a conflicting change that I added in.
And so somewhere in there, there might be like usually it's like right above. If you like scroll up a bit, there should be something to select which change to keep. Like usually what I see is at the top, there will be 3 little lines of text. One of like keep incoming change, keep current change, or keep both. And so that should answer your question, Raphael. You should be able to keep both of them. And what you can do is you can just manually delete the like the lines where it's like the little arrows and then head with current change, and then the other line with like arrows going the other way and the like random string of letters and numbers, as well as the like line of equal signs going across. You can just manually delete all of that stuff to keep all of them. But if you have the nice little button to just like say, like keep all changes, that's like the ideal.
Wrath, either way works. So source tree or fork is, as Courtney was mentioning, going to provide you with like this interactive way to select your lines. If you do it in Sublime, you just have to manually like delete the extra lines, like the extra arrows and equal signs that separate the different sections.
And VS Code should have the little like buttons to choose which one as well.
Mm-hmm. So Pardeep, the manual method is literally exactly that. Like you remove the arrows, you remove the equal signs, and then you like remove whatever part of the code you want to remove, or you keep everything if you want to keep everything. So it's like manually editing the text.
All right, so has everybody, you can push again after you remove the lines. You will need to stage them and commit these changes before you can push it.
Yeah, so that's the next step. After you guys have successfully resolved your merge conflicts, git add, git commit, and git push. So your branch is, or your remote repository will be updated.
All right, and so now we are at the final stage of what we need to do. So we're going to pretend that this is like a full, complete feature doing what we just did. And so now, like once you finish pushing your most recent changes onto the remote repository, what you're going to do is you're going to go onto GitHub itself and you're going to create a pull request. And so you can do that. When you go onto GitHub, you'll see in the top left-hand corner the branch name, by default, it goes onto the master branch. But in the little drop-down menu, you can find your branch name with your name on it. And you should see that there's an option for a new pull request. And so you're going to select that. And it should bring you to a page like this. So let me know when you guys get there. Let us know if there's anything, if you don't see anything along the way. All right, so you're going to make sure that whatever branch that you're wanting to merge in is merging into, in this case, it's master. In other cases, it's going to be the develop branch. In rare cases, you might want to try merging two feature branches, but such a case is going to be rare. But there are situations where you do it, but you just make sure that the two branches are as follows. So the branch on the right is going to be added to the branch on the left. Oops, I keep trying to scroll. You have the ability to look at all of the different commits to review the changes that are in the file, which you should absolutely be doing to make sure that you didn't add anything extra. And it's also a clean way to look at what's going to be added to the develop or the master branch. And once you're sure that everything that you want is in there, everything that you don't want isn't, you can press the green create pull request button. And at that point, you may run into further merge requests, or merge conflicts. In this case, you're not. And in practice, what's often going to happen, if this is the case, if you're running into a merge conflict, it's probably that you didn't update your local branch before you pushed to GitHub. So in this case, the step that you're going to have to take to resolve this is going to be going back to your text editor, to your command line, do a git pull, fix any conflicts there, and then you do the merge request again. But in this case, we're all good, so we're going to move on to the next step. This is what a merge conflict would look like if it's on GitHub itself. But if there's no conflicts, it'll look like what's on the right-hand side. You can have, for example, continuous integration set up. You can also have required code reviews, so have other people review your changes before you're allowed to merge. And then as long as all of the conditions are met, usually the conditions are set in the settings of the repo, you can then press the green merge pull request button, and that will merge it in with the master branch. So I'll let all of you guys go and do that right now. You can try and merge in your changes to master.
And so once you've merged in, make sure you select the delete branch after merge option.
Yes, good point.
Yes, I just want to note, looking at the repo, it looks like a lot of the merge requests were successful. So way to go, everybody who successfully merged in. So Raphael, to delete the branch, it's either when you merge the pull request, there's like an option. There's like a box that says delete branch after merging. It's easiest to select that. If that boat has already sailed, you can delete it in your local repo and then push that. And that'll delete in the remote repository. Right, Courtney?
That is I think it's a way, but you can also go and essentially do it retroactively. So I'm going to stop sharing the presentation, and I'll show you my other screen, and I can show you how that works. So here we're on main. So if I go to pull requests over here, well, right now it's automatically set to show if it's a pull request that is still open. But we can see here there's 4 closed pull requests. You can just remove the is open, or you can just click the for closed button. I'm going to do it this way. And my internet's slow, so this might take a sec. And what we can do is we can go to your branch and it will show the pull request. It shows that it was successfully merged. It shows all of the different commits that were added into it. And down at the bottom, you can see that the pull request was successfully merged and closed. And now you have the option to delete the branch. And you can go back and you can restore branches retroactively if in the future work needs to be like redone on what was happening, stuff like that. So that's why all of the commit messages that we did here, they're super important because sometimes you have to go back into stuff like this and look through it and make sense of it.
Yeah, so I think we're basically at the end of our tutorial, but I just want to add a little note here. Once you've merged and you've deleted your branch on your remote repo, make sure you also do that on your local repo. So the sequence of events is to git checkout master and then git branch delete branch name. And so that's just going to keep you from getting confused. And you know that like that branch doesn't exist anymore. You shouldn't be on it and making changes to it.
And remember, after you do a git checkout master, always do, especially after updating, do a git pull because it doesn't automatically update the changes from the remote repository onto your local version. You always have to do that manually. Oh, I think it's a git checkout main. GitHub is in the process of changing a lot of the language of that. And this is the first repo that I'm a part of that uses main instead. So let us know if you're successful in that. And if it is, you have successfully completed the workshop.
Yay! Nice. Okay.
So
way to go, everybody.
Yeah, way to go. Yes, that is it. All right, so do we have any last questions before we get going?
Take that as a no. Okay, well, I just wanted to thank everybody for coming. This is our first time trying to execute something like this. And it was a journey, but we made it.
We did make it. yeah, so thank you all for coming. Huge thanks to Amit for helping out with this. This was something that I had wanted to do for the longest time, but never had the energy to do alone.
My pleasure. This is
So
not a
it
one-man task.
was.
Great idea
Mhm.
though, Courtney. Who knew there was more to get than just push and pull? Oh my God, Ref. This is like an introductory talk.
Yeah, tune in
Let's
next
get
week
into
for the
rebasing.
yes. Tune in next week for advanced Git.
Mm.